So hi, by request from some users in Telegram, and I already had that request before, so let's go. I will make a little presentation of Aleph. First, I'm Moshe Malawar from the Codecraft Council of NULS and the lead developer of Project Aleph. What is Aleph? Aleph is an universal layer 2 platform. If you are in the blockchain industry, you know that there are blockchains, and sometimes when we need more over a blockchain, we make a layer 2. If you aren't in the blockchain industry or whatever, don't care. It's not important. Just use it as an SDK as you would any serverless SDK. That's the idea. Why are we making it? We want to decentralize the cloud. By cloud, I mean all the cloud provider there is here and there. For the Internet of Things, each brand has its own servers. They don't talk together, or only via big servers like Google's ones or Amazon's ones. It's not the goal of the Internet that we wanted. For regular decentralized application, the issues are delays, the time of committing data if it's on a blockchain, the cost of it, because the users needs to go and pay for each action using gas, whatever the platform, it's often the case. Not all of them, but most. Also for onboarding, the idea is the most possible way we don't want passwords. We just want to use our phone, security or hardware key or things like that. Passwords are kind of has-been. Also for storage, the decentralized applications have an issue with storage. If you want to store data on Ethereum, it will cost you thousands of dollars for a few megabytes. That's not possible. There are some solutions like IPFS, but you need to give incentives for people to store your data. So our layer 2 network will provide this incentive for IPFS, provide an off-chain state, so all the actions are instant. You don't need to wait for a block time. We'll see in a demo shortly after what it means. Free actions for the user. It means that either the network or the dApp creator will pay for the actions and storage, but not the end user, unless he wants to pay for it. And also cross-chain. Right now, if you have a dApp on Ethereum, a dApp on Neo, a dApp on EOS, etc., they won't be able to speak together, or even one that is simply on IPFS. We will need some way to bring them all together, be it on a blockchain or not on a blockchain. All the decentralized applications need to be able to talk together. So that's how we got the idea of making a network like this. You, as a user, will go to a front end. This web front end can even be stored on IPFS itself, incentivized by the Aleph network. It will talk either directly using lib peer-to-peer JavaScript primitives to the DHT-based network, or through API servers, it will talk to the Aleph network. The Aleph network itself will have distributed, as in geographically and as a redundancy of the data. So your data is stored on multiple places and you don't lose it, basically. And also incentivized. The people who will store your data will get money for it, so it will be secure for you, for IPFS. We will also have smart virtual machines. It's like parts of code, applications that will run on demand to have the server-side part of your application. You won't have traditional servers, you will just have virtual machines spawned on demand and kept alive as long as is necessary, shelved and re-put alive if it's needed. The Aleph network will also go and talk with blockchains for their ledger to be able to store data and be secured by the blockchain, because blockchains are kind of anti-fragile and really secure today. Not all of them, most of them are secure. We will secure ourselves on the blockchains and also get data from the blockchains. That also means that in the future we'll be able to use the smart contracts of the blockchains, maybe even accelerating them. This is a work in progress, as well as the virtual machine. This part and this part are a work in progress, not done yet. And be able to use assets from the underlying chains. So to sum up, we will have replicated data. All the data isn't everywhere, so it's scalable, because on current blockchain implementation, besides sharding and specific stuff like that, which is still in the works, everybody has all the data. It's not scalable. You can't store internet scale application. You can't store a Facebook, an Instagram, a YouTube, or whatever on a blockchain right now. You will need to be able to separate the data, get it very fast, and DHT are very good for this. They share the same technology that is behind a BitTorrent, for example, and it's used by IPFS that we use. There will also have per decentralized application subnetworks, and the subnetworks will be able to talk together. So the current state of Aleph, we have a proof of concept testnet, we have storage, we have the post data type, which is unitary data posting, and aggregate, which is a key value database. We don't have the virtual machines yet, and this presentation is outdated because we now have NULS and Ethereum. So in development, we have Neo, Ethereum is done, and here we can add EOS. I really need to upgrade this presentation, which was from April, and we are now in May, so Ethereum is now live. A bit of use cases. So for new application, we will provide an Aleph software development kit with an SDK for the server-side part with all the logic. You could even make a video game with the engine in the Aleph network. The idea is that it's instant, very fast, and fast enough for this kind of uses. And for existing blockchain dApps, we will give some SDK so they can patch their smart contract to support text transaction batching and message signing. So we can calculate the states between the commits and accelerate existing contracts. If what I said was technical, it's not important. We will just accelerate existing contracts. And also for the client-side code, so they will be able to talk through the Aleph network to their dApp and be able to store data and incentivize data for their decentralized applications. The transaction fees will also be lower than on traditional blockchain dApps, because for Aleph dApps you will only have the synchronization fees and storage fees, obviously. And for blockchain dApps, we will lower the fees thanks to batched transactions. For example, on NULS, right now you can make a transaction with a smart contract for 0.01, 0.02 NULS. With the sync fees and storage fees, you are per 100 message at 0.001 NULS only. So we are drastically lowering the costs. There is a part of tokenomics which is being worked on for the storage and computing incentivization. This is in the works. We'll give more details about that later. So, and as for the use cases, as we don't have our virtual machines yet, We can do all kind of data storage, pure data storage applications. Good example is a social network, for example, like Medium, Instagram, YouTube, Facebook, whatever, chats, for example. Internet of Things storage, like Aleph is light enough, since you just have to sign messages to send to Aleph. You can use very simple devices like this one, which is an ESP32, which costs $2, the chip on it, and send data directly from the chip or from a gateway if you already have your IoT fleet in place. You can send data and then analyze it and make actions based on it on the Aleph network. It's also useful for GPDR compliance for your application, because since it's based on APFS, you can send a request for all the nodes to forget your data that you posted. And if it's not critical for a virtual machine state, the network will forget it. It's useful for content, like you made a post, you want it to be forgotten, you ask the network and they will forget your post. As future use cases, once we have the virtual machine, obviously, which shouldn't be very long now, we will see. All kind of business applications, currencies, tokens, fungible token, non-fungible token, security, whatever. As financial applications too. Games can be done on it. Internet of Things action on local subnetworks with encrypted data, zero proof things can also be done, which is really useful for the Internet of Things feature set. Let's have a look at the current data structures that are live. An IPFS message as on Aleph message as an IPFS hash, a signature, a bit other fields, but what is important is the signature on the IPFS hash on the sender. The aggregate is a key with a value, and when you ask, you will get all the key and values merged down for a user. On the post has a type, a reference, which can reference itself on the content. The virtual machines and smart contract are state object links. Each item references the previous hash and is linked as a DAG. For example, you will have states of virtual machines just like smart contracts. If there is a call, it will create a new state here, and the same way around, you can create a new state here later on. So it's basically made as a DAG with subnetworks inside. It's a quite efficient way of working. We can have a look at a little demo. I'm logged in here on NULS space, which is a NULS dApp. Nothing in common with Aleph right now. It's just a NULS dApp to show you. I can edit my profile here. The profile is basically an aggregate. Hello, I'm a tester live. I can click on save. Maybe show. Whoops, my video is here. Yeah, please wait. We need to wait for the block time here, basically. And each action costs a little bit. If I upgrade, yeah, it's taken into account. Hello, I'm a tester live. So I can go there and say, hey, yeah, I will create a comment. The same, it will take a bit for the transaction to be validated on the network. And basically all the apps will either cheat showing you the action before it is done, or you will need to wait for X seconds for the actions to be taken into account. For some reason, yeah, okay, it showed. I did the exactly same dApp here. As you can see, MetaMask shows a notification because since we support both Ethereum and Aleph now, this dApp tries to get a MetaMask account. I will log in using a NULS address. I will just create a new wallet because I don't need to have funds in it. Yep. Let's do that. Add it. Yep. I will edit it. My name. Yep. It's me. Comment. And everything is instant. That's the good point of having a layer 2 network. They didn't need to hold any token because, well, actions are feeless. As I said, we support now the Ethereum network. We will see in a moment as I just did actions on the network here. Well, we need to wait for the block time. Testnet.nuls.world. If I go on the NULS testnet, normally you please transfer functions blocks. Yep, we see here a commit on the Rinkeby Ethereum network with an event here which is kind of long. Let's see why. Decode input data, and here we see protocol Aleph messages, and here two messages. The first messages, I guess, will be my IPFS. Demo effect. Cloudflare IPFS. Yeah, it worked. Content bio. I didn't enter anything as bio. I set a name Heya on the key profile. This is an aggregate. And if we see here, it's chain NULS, channel blog, sender TTN, which is our address, type aggregate, and we see the content of the aggregate. For my comment, the same can be done here, and I can see here this one. Yeah, content body hey, which is my comment, and the reference, which is this. The reference is this original blog post. And normally it should have been posted also on testnet. Well, I won't find it just looking at the blocks. But here it's on Ethereum and it's also on NULS. Every action you do is committed right now, both on Ethereum and on NULS. And if we add new backends, it will also be committed on the new backends. So thank you. So the name of the project is Aleph.im, and I'm Moshe Malawar, the lead developer of Aleph, and the NULS Codecraft Council member. So thank you everybody. Have a nice day.